Hi, good morning, and welcome to the ZP Developer Zone. As you can see today, the backdrop or the background here is a little bit different, and that's because I'm in Ireland at the moment, so I happen to be quite near Dublin at a conference that's called Curum, and apparently Curum is in Irish Gaelic, it means care. So yeah, I'm in a slightly different location today, but we still do the webinar for the ZP Developer Zone members. So I apologize if the sound's a bit up or the camera's not quite so good, but as I say, I'm sort of out of the office. Things are opening up a little bit more in Europe at the moment, and I'm able to travel to here. So welcome to the ZP Developer Zone. We do this every Thursday, practically without fail at 8 a.m. London time. So what I'll do now is I'm going to go into the actual presentation, and yeah, thanks very much. Okay, so the first thing I'm going to do is just describe the ZP Developer Zone. Hey, good morning, how are you? Hey, Saravana, good to see you. So what's going on here is every Thursday 8 a.m. we do the ZP's Developer Zone. It's probably worth saying that one of our ZP Developer Zone members is actually joining the company on Monday, so I look forward to that. So yeah, but let me just go ahead now. The first thing to sort of mention is that we do have the ZP Academy. The ZP Academy is a free resource that we put out there to sort of help developers and entrepreneurs learn about biosensors, and academics learn about biosensors, or the students learn about biosensors. We do this webinar, for example, every Thursday essentially without fail. And we're delighted that, hi, Hitcham, good to see you. And we do collaborations. I think, in fact, this week we're going to do a presentation from one of our collaborators, so it is pretty interesting. We also offer jobs up to our ZP Developer Zone members. So as I say, one of the members is actually joining the company on Monday. So we look forward to welcoming him. And we have this ZP Developer Zone. And the ZP Developer Zone is a webinar and a forum where we can kind of ask questions and debate things. And we're also going to organize some workshops as well to go along with these webinars. So this week's a little bit different because I've mentioned Hasim last week. Last week we were talking about Hasim. We did some a lecture on coffee. So Hasim was one of the founding members at the ZP Developer Zone, and he works in Indonesia, and he's quite interested in veterinary science. So when you look at this slide, this is some work from Hasim and Fatia, one of his colleagues, and what they were looking at. Obviously, cyanide is toxic. If it gets into the water courses or gets into the feeds, it can end up, unfortunately, killing the cattle. So Hasim's quite interested in veterinary science, and he's quite interested in the application of biosensors into veterinary science. And to be honest with you, I think that's really interesting to me as well. So Hasim, in this presentation, which I'm now presenting, but I absolutely say, it's Hasim's presentation. He talks about the cyanide, or the problem of cyanides in ruminants, things like cattle. He talks about the technology gap, and the technology gap for us at Zimmer and Pigok is you can detect molecules like cyanide. There's quick tests, which are paper, or there's more complicated tests, which involve analytical equipment. And he talks about the gap. He talks about his aims and his methods, what he was aiming to do, what his method, his conclusions, and then, of course, his thank you. So the first thing to say is the number of sort of cases. Now, I'm not sure, here the numbers are from 1990 to 2015. I mean, that's quite, that's 25 years. But he reports here that, in Indonesia, I think they have one of the highest, unfortunately, cases of cyanide poisoning of the cattle. I mean, what cyanide is doing is, the reason cyanide is toxic is it's similar enough to oxygen that it can bind to hemoglobin, and when it binds to the hemoglobin, it actually stops, obviously, the hemoglobin being able to carry oxygen. So essentially, you unfortunately, when you get cyanide poisoning, you're in a asphyxiation situation. Hemoglobin meant to bind to the oxygen, meant to carry the oxygen around the body and to the various organs. And unfortunately, cyanide is very strong at binding to hemoglobin, and it binds to the hemoglobin, and I think it's fairly irreversible. And so you're essentially losing the hemoglobin, and you die of asphyxia. It's the same as if you just were in an oxygen-less atmosphere, so not very pleasant. So they have had some cases of cyanide poisoning, particularly in the cattle, in the ruminants in Indonesia. And so Hassim, with his kind of veterinary hat on, wants to come up with a test for this. Now, the technology gap here that that Hassim describes is you can do cyanide detection using spectroscopy, chromatography. You can probably do it through titration, but essentially you either need equipment and a lab, and equipment and a lab plus and maybe a master's, not student, but master's trained scientist or a PhD trained scientist. So, it's not quick and easy to do, and it's certainly not something that you could do, readily in the field. And I think this is a good point, for us at ZP, that what we're really interested in doing is taking assays that could be done, but they would have to be done in a laboratory setting, and we want to reduce them down to something that's simple, low cost, and can be done in the field. And Hassim, is super interested in that. And I think in places, like Indonesia, where, I think Indonesia is it's a population of about 200 million people, but it's on thousands of islands. So it's just not practical to, be sending samples, around the place. They want to know the answers quite quickly. So this point of need testing is really pertinent in that, in the Indonesia archipelago. So as I say, Hassim is particularly interested in understanding the cyanide poisoning in cattle, and what he's developed in these slides is a Nafion polymer sensor for cyanide determination. When I looked at this picture, I happen to be in Ireland at the moment, so this looks like it is actually, the photograph looks like it is in Ireland. I'm not sure if it is, but that was his way of illustrating that this is what he's kind of trying to target. So they did some initial studies where they were using cyclovoltammetry, and now they want to sort of essentially improve the assay. So they're quite detailed in their approach on this. They're using a gold value screen printed electrodes at Zimmer and Peacock. We have carbon electrodes and platinum electrodes and gold electrodes, and I realized that I think gold is particularly good for cyanide detection, because if you're trying to do gold extraction, unfortunately, these gold miners actually use cyanide solutions to actually help with the gold extraction. So I can see why gold is a particularly good electrode for cyanide detection. So he's used he calls it a GVSPE, but it's a gold screen printed electrode. I always like Hassim's work because he's very consistent. He shows that electrochemistry is a true platform because he often likes to use DPV, differential pulse voltammetry. Last week when I was describing Hassim's work, it was a different target, but he was using differential pulse voltammetry. And that's the whole power, I think, sometimes of electrochemistry and biosensing, that you can change the electrode, but everything else, like the equipment, even the methodology, can all stay the same. It's just you change the sensor to make it, let's say, specific to what you want to do. Now, what he does is he doesn't just use the gold screen printed electrode. He tries to give himself better specificity by essentially, in part, blocking the electrode. And he does it by putting on a Nafion polymer on it. And he describes here that he has this Nafion solution of about 5% in phosphate buffer solution. And he actually electropolymerizes it. And he does it between minus 0.5 volts and 1.5 volts. And he does, for 10 cycles. He makes it so that's kind of how he prepares his electrode. He makes his test solutions by dissolving ferricyanide and ferrocyanide in probably also in PBS. He does his analysis by cyclovoltammetry. Now he also kind of interestingly contrasts it, and says that there is a low-cost test for cyanide, and it involves this color change paper. Apparently, this color change paper goes from yellow to brick red in the presence of cyanide. So that's kind of useful because there is a, let's say, low-cost test for it. But he does in this work actually do work sort of contrast between the paper test and the electrochemical data as well. So let's have a look at that. So this is his cyclovoltammetry. This is how he makes his electrode. This is this is what I like sometimes. It's a really simple assay. He's just taken the gold working electrode. He's functionalized it with 5% Nafion by just doing cyclovoltammetry. So he's just cycling back and forth, putting energy into the system and depositing the polymer onto the electrode. So a fairly simple method of functionalization. And then he actually tests with his source of cyanide, and he's able to show that he uses differential pulse voltammetry quite a bit. So he has a certain signal at 0, and then as he adds in the cyanide, the signal essentially goes downwards. So here he has the highest, let's say, peak current at 20 ppm, and then he's still getting a signal at 0.5 ppm. And I should have checked actually what the legal requirements are for, let's say, cyanide in the environment. There will be a European standard, and there will be a sort of FDA standard on this. But takes a gold electrode. Gold electrodes are intrinsically sensitive to cyanide. Anecdotally, they use cyanide in gold extraction. But this time he's functionalized the gold electrode with essentially a polymer layer, and that polymer layer is actually doing a lot of blocking of the electrode, but the cyanide can still get through the polymer. And then he tests it in fairly low concentrations, from 20 ppm down to 0.5 ppm. Now what he's doing here is he's saying, look, I'm going to compare the Picrate paper, and I like paper because it should be intrinsically low cost and quite easy to do. But he tests the Picrate paper at 0.5 ppm, 2 ppm, 5 ppm, 10 ppm, 20 ppm. And actually the paper, even after 60 minutes, doesn't change color. At 100 ppm, it does change color. So it tells you something about the sort of limit of detection of the paper technique, that at sort of approximately 100 ppm, you can get a brick red color, and therefore the farmer could do it. I'm sort of thinking that if you were trying to do an analysis of some complex matrix like soil, this would sort of suggest that if the cyanide contamination in the soil was like 100 ppm, you might be able to spot it by the paper. But if it was a bit more like 20 ppm, you actually wouldn't be able to see it. But of course, what he's saying here is actually he can see all these concentrations quite readily by the electrochemical method. And so the electrochemical method, not too surprising, is actually more sensitive than the colorimetric method. And that's, I think that is often the case, that if you, for example, you were trying to make a SARS-CoV-2 sensor and it was colorimetric, like a lateral flow type device, you can be more sensitive if you use the same assay but did it by electrochemistries. So it's not too surprising to me, but I think it's also quite positive, for obviously that the electrochemical sensor is actually more sensitive than the paper. So a couple of conclusions that Hasim made, and I think this is kind of interesting, that there is a test for doing cyanide detection in the field. It's this Picrate paper, and it goes from yellow to, hi Aftab, how are you? And it goes from yellow to red. But what he's done is quite a simple biosensor development. He's taken the gold value screen printed electrode from ZP. He's polymerized the Nafion on top of it, and that helps essentially block the electrode. But cyanide is quite a small anion, and so that cyanide is still able to penetrate that Nafion membrane. And then he's able to show that he can detect down to like 0.5 ppm, whereas he quite clearly showed that the picrate paper could detect maybe down to 100 ppm. So this 0.5 ppm, it's basically 200 times lower limit of detection. And now what he wants to do is, I think he actually wants to start testing ruminant feed, because maybe the cyanide, unfortunately, is getting into the ruminant feed through the cyanide's getting into the cattle through the feed. And he also wants to test serum. And so that Nafion membrane will be super useful, because when he tests these more complicated matrices like the serum and the feed, the Nafion membrane will stop non-specific signal, let's say, being picked up by the sensor. So this week, we were lucky enough to get some slides from Hasim. Hasim is one of the ZP Developer Zone members. You'll see him on the forum. He's particularly interested, as I say, in veterinary science. And because he is an analytical chemist and he works in quite a well-equipped lab, he does understand the tests that are available today. And he says, okay, you can do cyanide detection by, spectroscopy. You can do cyanide detection by picrate paper. But he's also an electrochemist, so he's able to actually take his knowledge and make these things into essentially electrochemical biosensors. So I'm just going to finish off and just say, this is Hasim in Indonesia, with essentially with his colleagues, and these are the guys who did the work. So I'm particularly appreciative of them. I'm appreciative of Hasim for allowing us to share the slides. And I'm also appreciative of Hasim, he's really carrying this message that, electrochemistry is a powerful technique. Last week, Hasim was working on detecting acrylamide in coffee. This week, he's able to work on cyanide detection in feed and in serum for cattle. And as I say, the reason the background is a little bit different on me today is I happen to be in Ireland. Things are opening back up. So, yeah, I think it's 1817. I've got to attend a conference now. As I say, I'm attending the QREM conference in Dublin. But yeah, thanks very much. I'll see one of you on Monday, as you will be starting with us on Monday. Hitcham, great to see you again. Aftab, great to see you. We need to talk about getting stuff up onto Gem, Aftab. But yeah, cool, guys. I will talk to you soon. I appreciate you coming again this week. And we will do a vlog and podcast at 8 a.m. on Sunday. I'm not expecting people to turn up. We leave it up on YouTube anyway. But yeah, we do a news and a wrap up for the week. I'm on Sundays at 8 a.m. Okay, I will sign off, and thank you very much, guys. I shall see you all very soon, and I shall see some of you in person even sooner. All right, take care, and bye-bye.